Now, another question. How do we find W, that's the solid, and that is the region inside the unit sphere, x squared plus y squared plus z squared equal to 1, and above the plane z equal to 0, and below the plane z equal to y. And so let's see what GeoGebra tells us. That's the sphere, and if you move the sphere around, and so if you move the sphere around, the red plane is the plane. This is the y-axis, and that's the z-axis, and the red plane is z equal to y, or y equal to z. And then the other thing that you have is the blue plane, which is z equal to 0. So the two plane, basically, if you think of the sphere as an orange, the two plane are slicing the orange into one wedge. So what you're trying to figure out is you're trying to figure out the area in the volume of that little wedge of the orange. So now to find the basically that volume, what we need to do is, if we are trying to find how to set up the integral, we have to look at the wedge. And what I see is in the z direction, if you look at the wedge that we drew in GeoGebra again, in the z direction, it's not quite simple. So how do I set up in either direction, either x direction or y direction or z direction? So if you really want to have a simple region, y direction is going to be a simple region, and y in the inner part. But we discussed that sometimes we have to figure out how to set up non-simple regions, because some regions, in this case, there is a way to find a simple region, but some simple solid, but some solids are not in either direction simple. So how do I set this up in the non-simple direction, which is a z direction? So if I go with a z direction, then what happens is that I have to figure out the projection over xy plane, which the projection over the xy plane is just that the sphere over here, and then it's just going to be the intersection of the sphere with the xy plane, and it will be cut off at the x plane. And so now that's the region. But if I set it up that way, I see that some part z ends with this plane, some part z ends up with this sphere. So I have to figure out which part is which, and that's not too difficult. I can actually plug in z equal to y inside the plane, and then through that solve for where the plane is not. It is splitting, but the solid is splitting, and so that's the way to go. So again, we're gonna divide the solid into two pieces. One piece is going to be the upper part is y. The other piece, the upper part, is the sphere. One piece is the plane z equal to y, so z equal to y, and the other piece is z equal to square root of 1 minus x squared minus y squared, which is the upper half of the plane. So the two pieces in there. And so how do we choose which is which? And it turns out that if I plug in z equal to y and I solve, I get x squared plus 2 y squared equal to 1, which is going to be an oval, and that is where the bounds are happening over here. And so this is the shape. This is the x squared plus 2y squared equal to 1 when you plug in z equal to y into here. And over the orange area, the little wedge is sitting between, z is sitting between 0 and z equal to y. And then between the other area, z is sitting between 0 and then the upper half of the plane. So we have to find this region. This region, the orange region, is when x is between -1 and 1, and y is between 0 and when you solve x squared plus 2y squared equal to 1, you get this. And here is D2, which is the pink part, and y is sitting between that and this, and x still going between -1 and 1. And so, and then you set up the integral, and integral is going to be equal to the double integral and the triple integral, and the inside one goes from 1 on D1 goes from 0 to y, on D2 goes from 0 to the upper half of the plane for, and this is when z equal to 0, z equal to y, and z equal to 0, and z equal to the upper half of the square root of 1 minus x squared minus y squared. And then you have to notice the outer parts. Outer parts are just setting up how we set up the regions. This is region 1, D1, and this is region D2.